So now we're going to take a look at some examples of equations, and we're going to go through how we balance them. And as we go through, we're going to take a look at some strategies that we can use to help make the balancing process a little bit more efficient. Okay, so we're going to take a look at some examples of balancing equations. Okay, and you only get good at balancing equations if you practice. So you really need to do lots and lots of practice so that you develop the little strategies that you can use to make this process go more efficient and more efficiently. So let's take a look at the first one. So we have here the reaction between, this is a molecule called propane and oxygen. So this is the combustion of propane to produce carbon dioxide. And then we also get water vapor, right? So in your propane tanks, your propane grill, wherever you have propane used as a fuel, this is the equation that represents the reaction that is occurring. So again, what we're going to do, we're going to place a little line in front of each of the formulas so we know where our coefficients can go. And then what I like to do is I like to go ahead and I'll list the atoms that I have on both sides of the equation. So on the left side, I have carbon, I have H, and I have oxygens, and I should have carbons, H's, and O's on the right side as well, right? So you have to have the same types of atoms on both sides of the equation. So we're going to count. On the left side, I have 3 C's. On the left side, I have 8 H's. On the left side, I have 2 O's. I do the same thing on the right side. On the right side, I have 1 carbon. Remember, 1 is understood to be there. We don't need to put it in. It's just understood. On the right side, I have 2 hydrogens. And on the right side, you can see now my oxygen is split between the CO2 and the H2O. I have a total of 2 plus that 1. Remember, 1 is understood. 2 plus 1 gives me 3 oxygens on the right side. Okay, so right away now, this brings us to our first strategy. If you notice an element like oxygen, if it's split between 2 different places on one side of the equation, right, we want to save and want to balance that one last. So in other words, start with the other elements first, where it's fairly straightforward to see where they are. And then hopefully by the end, balancing the oxygens is going to be a little bit more straightforward than if you try to balance that initially. Okay, so that's a suggestion. You can take it or leave it, but that's a strategy that will help you get to the answer, usually a little bit faster. So let's balance the other ones first. So we can start with the carbons. On the left side, I have 3 carbons here on the C3H8. On the right side, in order to make 3 carbons, I need to put a 3 in front of the CO2. So 3 times 1 is going to give me 3 Cs. But now I've changed also my oxygen. So 3 times 2 is 6 plus, don't forget that 1 oxygen in the H2O. So 6 plus 1 is going to give me 7 oxygens. Okay. Now we said we're going to leave the O's till the end because it's split between 2 places. So we balance the C's. Let's balance the H's now. So for the H's, let's see, we have 8 H's on the left side. We need to make 8 H's on the right. So currently the subscript here is 2. So 2 times what gives me 8? Well, 2 times 4. So 4 times 2 is 8 H's. But now I've also changed my oxygens, right? So now the 4 times the 1, that's understood. So that's 4 O's plus the 3 times 2 here, 6. So 4 plus 6 gives me 10 O's on the right. And now I need to balance my O on the left side. I need to make 10 on the left. So 2 times what gives me 10? Well, 2 times 5 is going to give me 10. So you can see here, if I save the O's till the end, and to balance it, it was just a one-step process, right? If I'd started with the O's, I would, probably take me a couple minutes longer. I'll end up with the same answer, yes, but it'll take me a little bit longer. Okay, and then I didn't do anything to the coefficient for the propane, so that's 1. It's understood to be there. We can leave it out. So this is your balanced equation. You can double check at the end that we have the numbers on both sides. Okay, so that's your first strategy. Try to balance or leave the element that is split between different places to the end and balance the other things first. Okay. The other strategy that we can use, and we'll do a similar example here. So let's take a look at propane's cousin. We'll call it butane, C4H10. And it's undergoing the same combustion process. We get the same products. And we're going to put our lines in front to see where the coefficients are going to go. We're going to list the atoms. Again, we have carbons, H's, and O's. Okay, we're going to count on each side. We have 4 C's on the left, 10 H's on the left. We have 2 O's on the left. On the right side, I have 1 C, I have 2 H's, and I have 2 and 1, 3 O's. All right, so again, same strategy as before. We're going to balance. We're going to save the O's till the end, balance the other ones first. So I need to make 4 carbons on the right side. I'm going to put a 4 in front of the CO2. 4 times 1 gives me 4. I've changed my oxygens now. 4 times 2 is 8. Plus that one is 9 O's. Balance my H's. I have 10 H's here on the left side. I need to make 10 H's on the right. So 2 times what gives me 10? 2 times 5. 10 H's. I've also now changed my oxygens. So 5 times 1 is 5. Plus that 8 is 13. Okay. So I balance my C's, balance my H's, and now my O's, I need to balance it. So now I need to make 13 O's on the left side, and 2 times something has to give me 13. Okay, well, a simple way of saying that is, well, what is 13 divided by 2? And we can actually use that 13 over 2 over here. So if I do the math, right, 13 over 2 times 2, the 2's cancel. So that actually does give me 13 O's on the left side, right? So they are balanced. However, I just used a fraction or a decimal, in other words, because this is the same as 6.5, right? It's the same as a decimal number. And I can use it to balance the O's to begin with. However, if you use, and again, this is a strategy, if you use a fraction or decimal to balance, then you need to get rid of it. I need to convert it to the smallest whole number possible. So convert to a whole number at the end. Okay, so you cannot leave it as a fraction or a decimal. So cannot leave as a fraction or a decimal. So how do I get rid of the fraction? Well, what I can do is I can take that, I can multiply that coefficient by 2 to get rid of the denominator. And if I multiply now remember, I use 13 over 2 to balance the O's. So technically my equation is balanced, but I need to make this a proper coefficient, meaning it has to be a whole number. So now I'm multiplying it by 2 to convert it to the smallest possible whole number. If I multiply this by 2, I have to multiply all the other ones by 2 as well. Okay, because this is an equation, we have to do whatever we do to one side, we need to do to all the other things. Remember, 1 is understood to be here in front of the C4H10. So what I end up with then, as my new coefficients now, is now I have 2 C4H10 plus 13 O2 to give 4 times 2, which is 8 CO2 plus 5 times 2, which is 10 H2O. Okay, and if I count my atoms again, okay, so I have my C's, H's, and O's. On the left side, I have 2 times 4, which is 8 C's. On the left side, I have 2 times 10, which is 20 H's. On the left side, I have 13 times 2, which is 26 oxygens. On the right side, I have 8 times 1, I have 8 C's. On the right side, I have 10 times 2, which is 20 H's. And when I look at my oxygens, I have 8 times 2, which is 16, plus the 10 O's and 10 H2O's. 16 plus 10 is 26. All right, so this is my properly balanced equation, 2, 13, 8, and 10 being the smallest. These are the smallest whole number coefficients that we can use to balance this equation. And that's what you want to get to. Smallest whole number coefficients. Smallest integers, in other words, are what you need. Okay? You can use fractions or decimals to help you balance the equation in the first place, right? Because this equation up here is balanced, right? But it's not in the proper form. You have to get it to small whole numbers. Okay, so that's the second strategy. The last strategy we'll take a look at is when we encounter polyatomic ions in in our formula, in our equation. So let's take a look at an example. Let's say I have calcium. We'll do calcium chloride. So I'm sorry, we'll just change that up a little bit. We'll do calcium phosphate. So Ca3 PO4 2 reacting with let's say aluminum sulfate. So aluminum sulfate will have the chemical formula Al2SO4 3. And then this would be products here will be AlPO4, aluminum phosphate, and then we get calcium sulfate, CaSO4. Okay, anyway, look at this and think, wow, there's a lot going on in this equation, and you'll be right. There's a lot going on, but we're going to approach it the same way. So we're going to put our little lines in front. That's where our coefficients are going to go, and then we're going to list the atoms that we have on both sides of the equation. So on the left side here, I have calcium on the right. I have aluminum on the left, aluminum on the right. Okay, and then the next strategy is the next thing we're going to see. If you see or if you notice the same polyatomic ion on both sides of the equation, okay, what you want to do, and again, this is a suggestion, you want to balance it or balance them as ions. In other words, don't separate them into individual atoms. Okay, and what I mean by that is, on the left side of my equation here, I can see the phosphate, the PO4. On the right side of the equation, I also see the PO4. On the left side of the equation, I see the sulfate, the SO4. On the right side of the equation, I also see the sulfate, the SO4. So what I can do, because they're the same on both sides, I can balance them as phosphates, and I can balance them as sulfates. I don't have to separate them into S's and O's, and it'll make your life a whole lot easier if you do it this way. And again, that's if you see the same polyatomic ion on both sides of the equation. So on the left side of the equation now, when I do my count, okay, I can see that there are 3 calciums. On the right side of the equation, there's 1. On the left side, I have 2 aluminums. On the right side of the equation, I have just 1 aluminum. On the left side of the equation, I have 2 phosphates. On the right side of the equation, I have just 1. And when you start balancing these equations, what you can do is you can go ahead and use a pair of parentheses, put it around your polyatomic, so that way when you look at it, right, your eyes visually gravitate towards treating that as an entity rather than trying to separate it, right? So on the right side, you have 1 phosphate. On the left side, I have 3 sulfates. And on the right side, I have just 1 sulfate. So I'm going to put parentheses around it to help me to be a visual clue. Okay, so now what I need to do is I need to go ahead and I need to balance my atom or my polyatomic ion. Doesn't matter where you start, you're going to end up with the same answer either way. So let's look at our calciums because that's the one listed first. All right, so I have 3 calciums here on the left. I need to make 3 calciums on the right. Right now I have just 1 calcium. Okay, so 1 times what gives me 3? Well, 1 times 3. So I put a 3 in front of this. This makes it 3 calciums, but then I've also changed my sulfates now. So now I have 3 sulfates on the right side. And guess what? They automatically balance each other. On the left side, I have 2 aluminums. I need to make 2 aluminums on the right. I only have 1 to start with. So 1 times what gives me 2? 1 times 2 gives me 2. So now I make 2 aluminums. Okay, but now I've also changed my phosphates to now 2 phosphates. Guess what? It now balances my phosphates, balance the aluminum and the calciums. Right, that's your balanced equation for this reaction. So that's the third strategy involving polyatomic ions. If you see them on both sides of the equation, you want to treat them as an entity rather than separating them. This will be dependent upon your ability to recognize your polyatomic ions, right? So you had to memorize a whole list of these. This is one situation where that is going to be particularly useful, is your ability to recall what those polyatomic ions are. So feel free to use any or all of these strategies as you balance your equations. And again, really, it does boil down to trial and error. But the strategies that I just shared with you makes the trial and error a little less a little less of just guessing rather than approaching it systematically.